Big ideas need a proving ground, a place to test who is really best. For computer vision, that place was ImageNet. ImageNet is a giant dataset, over 14 million images, each one labeled by hand, spread across 1,000 different categories. 1,000 kinds of dog, mushroom, vehicle, and everything else. Every year, research teams competed to classify these images, and the error rate on that competition became the official scoreboard for the whole field. Lower error was better. For years, the handcrafted methods from Part 2 crawled along, stuck at roughly 25% error, 1 in 4 wrong. Progress was slow and grinding. Then, in 2012, everything changed in a single afternoon. A deep convolutional network called AlexNet entered the competition, and the error rate collapsed. It was not a modest improvement. It was a landslide, and it converted the entire research community almost overnight. What followed was a furious race to go deeper. A network called VGG showed the power of stacking many small 3x3 filters. But let's pause on why 2012 of all years was the moment. 3 things finally lined up at once. The core ideas were actually decades old. What was new was data. ImageNet finally gave them millions of labeled examples to learn from. In hardware, researchers found that graphics cards, GPUs, built for video games, could train these networks tens of times faster. Ideas, data, and compute arriving together, that is the combination that set off the explosion. Then AlexNet solved a stubborn problem. Very deep networks had become almost impossible to train. AlexNet added a clever shortcut, a skip connection that lets the signal jump straight past a group of layers. That one trick made it possible to train networks over 100 layers deep, without them falling apart. And with that, accuracy on ImageNet passed the human benchmark. In just a few short years, machines went from clumsy to genuinely superhuman at naming what is in a picture. So next, the natural question: how do we actually train one of these?